Awesome! Welcome to Autism Story Time. Horrible Science Killer Energy Part 4. The first bit I'm going to read is the answer to the science experiment I've read in the last one. Let me just unblock this. So I'm going to read you the answer to the science experiment I did in the last one. That one, just so you can remember. And this is what the answer is. C. The shape is powered by heat energy. It might move at first because of drafts in the room, or wobbly as it balanced on top of the pen. But it really gets going when the hot air rises off your hand. This proves the first law is right when it says that heat energy can make things move. So that's the answer to that. And the time is 9:37 and it is Wednesday the 26th of June, and the name of the chapter is called Horrible Heat. And that's good to represent the heat today in the UK. It was about 26 degrees. I'm sweating, but I can't have the fan on and do the story time, so I'm going to get hot while I'm reading it. So, wish me luck. But luckily, it's only 4 pages that I'm reading at the time. So, Horrible Heat. This chapter lets you into some sizzling heat secrets. This chapter lets you into some sizzling heat secrets, including how the second law affects the entire universe and how an extremely important sausage changed the course of history. I have no idea why sausages come into this, but let's read on. What that? You don't remember what the second law says? Well, it's the one that says heat energy goes from a hot object to a cooler area. And actually, comes to think of it, the second law actually sneaked into that experiment in the last chapter. So, we're on this picture now. In the experiment, heat energy passed from a hot area, your hot sticky hand, to a cool area, the air. Yikes! And as I said, the second law has a huge effect on the whole universe. Take this nice hot cup of tea. Hot. Is my tea ready? Do that. The second law says all the time the cup of tea is losing heat. In other words, it's cooling down. If you blow on the tea, it will cool even faster. Your breath blows away the air warmed by the hot tea, and the heat energy flows more quickly into the cooler air. So like when you blow on hot food, it gets cold. Scientific note. The greater the temperature difference between a hot and a cold area, the faster the heat will flow between them. In half an hour, the tea is disgustingly lukewarm. I hate when it goes cold. When I take a sip, I need to spit out because that's horrible. It makes me want to throw up. Lukewarm. Oi, where's my blooming tea? In an hour, it's stone cold. Stone cold. Oh, yikes! The only way to make the tea hot is heat it up again. In other words, to add more heat energy. And what true for the T is also true for everything in the entire universe. Yes, the second law says that everything from galaxy to gravy, from hippos to hot water bottle, is forever cooling down on the other side of the cosmos. We're losing heat, Captain. It's that blasted second law again. And the only way to keep anything hot is to chuck in more heat energy. And that means you'd better eat your that revolting right button and digest it and turn it into heat to replace the heat energy you lost today. So the bit that I read before. We're losing heat, Captain. With that bloody second thingy. So, 2 more pages, I'm done. Okay. And that rotten old second law has some even worse news for you on page 141. So we'll get there in a bit. But first, it's time to find out a bit more about a real hot topic. Killer Energy Fact File. So I'm reading that. I'm going to show it you now. Then I'm going to show it you when I finish reading. Name, heat energy. 1. If you looked at this speck of dandruff through a super powerful microscope, yes, more powerful than the microscope in the world, you see tiny atoms that make it up. 2. The atoms are wobbling. This movement is what we call heat energy, and the hotter the atoms are, the faster they wobble. With me so far? So the hotter they are, the quicker they move. Killer detail. 1. At absolute zero, minus 273 degrees, they can't move, not even an itsy-bit mini wobble. The atoms have no heat at all. So when it's super, 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 super cold, they can't move. And when they got heat, they move. 2. Very low temperature can preserve dead bodies forever. Page 42 will send a cold shiver down your spine. So I read that. And we're all going to read that in a bit. Because in each bit we're going to try and read 2 chapters. So that's 8 pages per bit. So last page for this little part. Then tomorrow I'll read another 4. Then I'll upload it. And that's how it's going to go. Every other day I'm going to upload. Just so you get the idea. Sorry. Pardon me. Hot, so hot theories. You can't expect scientists to grasp all this straight away. An early idea about heat were definitely on the tepid side. Here's Swiss scientist Barry Bravos, 1751 to 1839. So this. Some people think that hot and cold are invisible substances. They call the cold substance frigoric, I think. Before it's obvious that cold is simply lack of heat. Oh yes, and the hot substance is called caloric. So I read them. Of course, this caloric was a load of hot air, but Bravos wasn't proven wrong until American scientist Benjamin Thomas Count Rumford, 1753 to 814, took on a boring job. He worked as a minister for war in Bavaria, Germany, and he was watching a cannon being bored by a drill. The cannon got very hot, and if you believe in God, you might think that the cannon would run out of the hot stuff after a while, but it didn't, so it kept getting hotter and hotter and hotter. So Rumford realized that heat can't be a substance, it must be a form of energy. That was picked up from the rumbling of the drill in the same way that rubbing your hands make them feel warmer. In 1798, Rumford proudly announced his discovery at a meeting of the Royal Society, and no one took any notice. That must have been bored, I think. So, tomorrow I'm reading the chapter that goes Terribly Tacky Thermometers. So, stay tuned for that. This bit, I'm going to read 7 pages. But some chapters are going to be longer now. And this chapter is called Terrible Tacky Thermometers. The measurement of heat energy is called temperature. I hope you're suitably impressed by this fact. But early scientists had a problem measuring heat as no one had got around to inventing the thermometer. After combining dozens of scientific junk shops, we've uncovered a selection of ancient thermometers. So now I'm reading this. Ye old scientific junk shop. Let's hope your school equipment isn't this old, even if your science teacher might be. Air-filled thermoscope, invented by Italian genius Galileo Galilei in 1564 to 1642, used air and water to measure temperature. Albert Einstein eyeballs Galileo's skull. So Albert eyeballs Galileo skull. And that's the thermometer. Improved version devised by German scientist Otto von Guericke in 1602 to 1682. Isaac Newton wig and teeth. The improved one. Isaac Newton's wig and teeth. Water-filled thermometer invented by French Dr. Jean Rey in 1631. It wasn't much good at measuring below freezing. Can anyone think why? Some of the earliest mercury thermometers were made by German Daniel Fahrenheit 1686 to 1736. In 1714, mercury freezes at a very low temperature and boils at a very high temperature. Albert's brain, thermometer, and another one. That's the one you would see today. Five more pages. Dare you discover how to make your own thermoscope? You will need a small plastic bottle, ideally no more than 30 ml with as small an opening as possible, sticky tape, teaspoon, scissors, a large blob of blue tack, 3 glasses, food colouring, a light coloured plastic drinking straw. what do? Half fill one glass with water and add a few drops of food colouring. Stir well. Then 2. Half fill the second glass with ice. The freezer. Be careful not to touch the ice with your bare hands. Being very cold. 3. Half fill the third glass with hot water from the tap. Don't touch the water either. It could be scalding. Don't want to burn yourself. 4. Stick the straw in the bottle and block up the rest of the opening with blue tack. Wrap sticky tape around the blue tack so no air can get into the bottle except through the straw. Five. Gently squeeze the bottle and turn it upside down so the end of the straw is in the coloured water. Coloured water will fill up the straw. Now stop squeezing the bottle and put it the right way up. You should see a band of coloured water in the straw. 6. Place the bottle in the glass of ice and then in the hot water. What do you notice? A. The water in the straw goes up in the ice and down in the hot water. B. Or does the water in the straw go up in the hot water and down in the ice? Or C. The water in the straw becomes lighter in the ice and darker in the hot water. What do you think happens? Going to give you a few minutes to work out what happened before I give you the answer. Actually, I'll give you the answer in the next video. So I'm going to leave it there. I know I said I'm going to read a few pages, but I don't want to read on because I want to give you a chance to do that experiment. If you want to, that is. And if you don't, that's fine. But I'm giving you time. So in the next one, I'm going to start off with the answer, then carry on with the chapter. So stay tuned for that one, and thank you for watching. Bye.